Okay, so welcome back. So now, a question that ultimately comes up, or that will come up and naturally comes up in the study of sequences is the behavior of the sequence as n gets arbitrarily large. And it makes sense that this would come up because if we can define a sequence in terms of an explicit formula, and we can represent that formula as a function of n, where n are the positive integers, then it makes sense that we'd like to know what the behavior of that is, just like we do with the limits of functions. We can see the limit of a sequence. So let's use a few examples to see what we mean. So if we look at this function here, we've got 1 plus 3n, which if we list out the terms, some of the terms of the sequence, it looks like this. And we say that it looks like that the sequence is just getting arbitrarily bigger, the terms. The last term, the term is getting arbitrarily bigger as n gets bigger. So what we would say is that a sub n is approaching infinity as n approaches infinity. Okay? Now, what about the next one? So notice this one here, we're starting with 1 and we're subtracting off a power of a half. Okay? And again, this is the same sequence that we just studied in the previous videos. And so we've got this sequence of 1/2, 3/4, 7/8, and so on. Okay? Now, notice that it seems like we're starting at 1/2, then we're going to 3/4, which is bigger, and 7/8, which is bigger than 3/4, and then 15/16, which is bigger than that. But it seems like it's not going off arbitrarily larger. It's not getting arbitrarily larger. In fact, these numbers are getting bigger, but they're very close to each other, right? In fact, very close to 1, right? In fact, if we keep going, right, we have 31 over 32, right? And then we've got, what's the next one? 32, 64, of course. 64, so we'll end up getting 63 over 64, 127 over 128. So even though the numerator and the denominator are getting arbitrarily large, they're staying within a difference of 1, which means they're getting closer and closer to 1. So we would say that in this case, a sub n is approaching 1 as n approaches infinity. Now what about this one here? So we've got this alternating sequence, right? -1 to the nth power, and all we have is -1, 1, -1, 1. So this is alternating back and forth, but it's not approaching any specific value, right? So it's alternating right, from 1 to -1. But it's not approaching any particular value. Okay? Now, what about the last one, D? Well, if we look at D, what are we doing now? We're taking this, basically the sequence in C, and we're dividing by n. So we're taking this new sequence, and so now what do we have? We have an alternating sequence, right? Because of the -1 to the nth. But now we're dividing by n, which means now what's happening? We start with -1, then it goes to half, -1/3. So it looks like if you take the absolute value of these terms, if you were to ignore the negative signs for a moment, this sequence is getting closer and closer to what? Well, we start with -1, but then the numerators are staying 1 and the denominators are getting bigger. So it looks like we're alternating back and forth on opposite sides of 0, but the numbers themselves are getting closer and closer and closer and closer to the value of 0. Okay, so in this case we would say that a sub n approaches 0 as n approaches positive infinity. And so furthermore, we can look at the graphs of these sequences, right? So we can see the behavior from a function point of view, right? So again, we've talked about limits of functions, and so it makes sense that we can look at these in terms of the graphs, right? So well, A is just a straight line. So A does something like this. And so what was it? It was, what was it again? Hold on a second. It was, one plus 3n. And then B was 1 minus 1/2 to the n. And this is a sub n equals -1 to the n, and then this one was a sub n equals that. Okay. Okay, so this one, if we were to sketch this one, I'm just doing a sketch of a graph, but from this one, this is approaching 1. It starts at 1, and it's getting smaller. So it starts at half. So it starts at a half. And so what's happening? We start at a half. And it seems like it's getting closer and closer and closer to 1, right? But it's never going to reach 1. And this one here, if we just look at it this way, so this function is just basically going looks like that. It's just bouncing back and forth between 1 and -1. Now this one here, it starts at what? -1. But then as it bounces back and forth between positive and negative, it's getting closer and closer to 0. So this would be a half, right? Let's say it's there, then it's getting negative 1/3. Let's say it's there, then it's going to be 1/4, and then negative 1/5. And so we can see that it's bouncing back and forth, but it's getting closer and closer and closer to 0. Okay, so again, the graphs, if we can treat these as functions, we can start applying some things that we know about functions and use that to our advantage, as you'll see later on. Okay? Have a great day. I'll see you next time.